For section 2.7, we're going to be looking at equations and inequalities that contain absolute value symbols. Your essential question for today is, how can I solve an absolute value equation or an inequality? Now, we need to start out by talking about absolute values. There are two answers to every absolute value equation, one positive and one negative, and I'm going to prove that to you in just a second. I want you to remember the definition of absolute value. The definition of absolute value is the distance between that number and 0 on a number line. So if I ask you for the absolute value of 3, you would say 3 is 3 places away from 0 on a number line. If I would ask you the absolute value of negative 200, you would say 200, because negative 200 is 200 places away from 0 on a number line. That being said, let me put an X in the absolute value. If I ask you what number is 5 places away from 0 on a number line, what number is 5 places away from 0 on a number line, you would say 5. Hopefully, you would also say negative 5. Negative 5 and 5 are both 5 places away from 0 on the number line. And that's where this comes from. There are two answers to every absolute value equation, one positive and one negative. Let's look at some more complicated problems. If I would ask you to solve this problem, it reads the absolute value of x minus 2 is equal to 2. The first thing you've got to recognize is that, remember, every absolute value problem has two answers, one positive and one negative. So the first thing I'm going to do is I'm going to set that quantity, x minus 2, equal to a positive 2. I'm also going to set that quantity, x minus 2, equal to a negative 2. And there's my two answers. I'm representing my positive 2. I'm representing my negative 2. Now I've got two completely separate problems that I'm going to solve, and that gives me my two final answers. In both cases, we're going to add the 2 over. Over here, we're going to add the 2 over, and we're going to get a 4. Over here, we're going to add the 2 over, and we're actually going to get a 0. Now, the way that you write your answer when you've got more than one is you put a 0, comma, 4, and you put it in braces. Don't put it in parentheses. If you put it in parentheses, you're telling me it's interval notation or it's an ordered pair and I need to graph it. It's neither. You're telling me there's two solutions. Both 0 minus 2, the absolute value, equals 2, and 4 minus 2, the absolute value of that, equals 2. You're telling me there's two solutions. Now let's take a minute and let's look at inequalities. What do you do when it's an inequality? Well, there's two answers to every absolute value inequality as well. And automatically, when you've got two inequality symbols, it becomes compound. When it becomes compound, it becomes either an or inequality or an and inequality, like we learned yesterday or last class period. So how do you tell which is which? How do you tell whether it's an and or an or? Well, you look at the original problem. If whatever is in the absolute value is less than something, that's automatically an and inequality. If whatever is in the absolute value symbols is greater than something, that's automatically an or inequality. So you look at the original problem and the original sign. If the absolute value is less than, it's an and. If the absolute value is greater than, it's an or. Now let's look at a problem. Here I've got the absolute value of x plus 1 is less than 3. Since the absolute value is less than, that makes that problem automatically an and inequality, meaning when I graph it, I'm only going to take where the graphs overlap. Now what I'm going to do is I'm going to do exactly what I did on my last problem. One of them is going to say less than or equal to a positive 3. The other one, I'm going to change that to a negative 3. Now the minute I change that sign from a positive 3 to a negative 3, I need to flip my inequality sign. So here I kept my inequality sign and my number the same, but when I went over here, since I changed my positive 3 to a negative 3, that's similar to multiplying by a negative, and when you multiply or divide by a negative, you flip these signs. So I had to flip that inequality sign. Now I'm going to go ahead and solve this by subtracting my 1 over. And now I'm going to graph and actually get my final answer. So I'm going to get my graph out. My negative 4 goes to the left of my 2. That reads x is greater than or equal to 4, but at the same time less than or equal to 2. Making my answer the set of all numbers between a negative 4 and a positive 2. Let's go ahead and look at problem number 2. Problem number 2, if you look at the original problem, we've got an absolute value greater than. Anytime you have an absolute value greater than, it becomes an or problem. So in this case, we've got an or problem. Now once again, My first problem I'm going to keep the same, greater than 2, greater than 2. For my second problem, when I go from a positive 2 to a negative 2, I'm going to have to flip that inequality sign. So here were my changes. I kept this the same. I changed these signs. Add my 3 over, I get a 5. Remains an OR problem. Add my 3 over, I get a 1. Now I'm ready to graph and shade. Since this is an OR problem, we're going to take all of the graph. Whether it overlaps or not, we don't care. X is greater than 5 is in that direction. X is less than 1 is in that direction. And the way we would write this in interval notation is negative infinity to 1, union 5 to positive infinity. So in other words, all the set of numbers between negative infinity and 1 or 5 greater to positive infinity would be my solution. Last but not least, I want to look at a problem with an absolute value not originally by itself. So the first thing I notice when I'm looking at this problem is this negative 3 is not in the absolute value. Now I can't put things in an absolute value or take things out of an absolute value, but what I can do is get them out of the way. Before I determine if this is an OR or an AND problem, before I go ahead and split this into two separate problems, I need to get rid of that negative 3 first by using my inverse property and adding it over. Otherwise my answer would be incorrect. So if we add that 3 over, we actually have a 5. Now I'm going to look at my original problem, and this says the absolute value is greater than. Now that the absolute value is greater than, I know that this is going to be an OR problem. So over here I'm going to have x plus 2 is greater than 5. I'm not going to change anything. And on the right side, I'm going to have x plus 2 is less than a negative 5. So I'm going to flip both of my symbols. I'm going to subtract my 2 over and get a positive 3 there. I'm going to subtract my 2 over and get a negative 7 here. Since this is an OR problem, remember when we graph this, we take all of the graph, not just where they overlap, all of it. This reads greater than 3. This reads less than negative 7. Making my answer all of the numbers between negative infinity and negative 7, or all the numbers between 3 and infinity.